Right. Hello, everyone. Welcome to Amplifying F Sharp. First of all, Happy New Year to all of you. I hope you had a great Christmas break, and we are all ready and back to have more sessions on Amplifying F Sharp. Before we go into the session, I would like to say a couple of things about what is new in Amplifying F Sharp this new year and what we have been working along with the community to keep working on initiatives. So first of all, we have a redesigned website. As you can see, now we have new colors, and we have more tabs or more landing pages that are basically the new initiatives that we are working on. We have the new three landing pages. The first one, which is the one I'm really excited, is a F-sharp, the Essential Lectures. This is a free online course based on Ian Russell's book, and which himself is the instructor for this online course that will go from 12 weeks of content, and we will have as well some bonus sessions with inviting people from the community about developing desktop apps, mobile apps, web apps, and all of that. But you can see here, if you visit the Amplifying F Sharp github.io F Sharp Essentials, you will see all the information there. It starts next month, and it's live. It's going to be in a weekly basis. Normally it will go on Wednesday, but if you give us your email, we will notify you when we are going to go live and all of that. All of these sessions will be recorded and stored in YouTube. They might not be available right away because we want to do some light editings to make it more enjoyable. But yeah, they all should be on our YouTube channel. So yeah, please check this out. The next one is a initiative that we want to help the open source maintainer, and if someone is feeling like they cannot continue, or they are suffering from burnout and all of that, please read this intro here that will explain a little bit more what are we talking about. But yeah, I mean, maintaining an open source is not a easy work, and sometimes it's a miserable work. And we are here for you. If you want to contact us, either myself, David, Edgar, Florian, or Jimmy, yeah, just let us know, and we can listen to you, we can hear you, and we can share our experiences there. So please check this out as well. And the last one, and know that I guess new, is that we all working we all collaborate on Amplifying F Sharp. We don't get paid by this. This is a non-profit, organization, and we are not even a non-profit legal organization. We're just a group of guys that are collaborating together to get some stuff done. But if you want to check, you want to know more about us, and you need something from to be done in the F Sharp ecosystem, you can look at the hard tab, and you will see our descriptions here, how you can contact us, and what we do and all of that stuff. So yeah, please check this out. Yeah, if you guys don't want to say anything else, I will start presenting the session. No, that sounds good. Right. So for this session, if you go to Amplifying F Sharp github.io, you will see that we in the sessions tab, we have a bunch of sessions that we had during last year. The last one was Maxime from the F Sharp from the Fable compiler. Maxime gave us a great overview about the Fable compiler, how that works, how that is different from the F Sharp compiler, how they interact each other, how you can also start contributing to the Fable compiler. So if you're interested on chiming in and help or contributing to Fable, please have a look at this session. You have a great YouTube video here with all the details from Maxime. For this week, though, I proposed a session which is about code generation using F# code, and created the library last year at the end of the year most likely, and that the name is Fabulous AST, which is, I will explain a little bit in detail what that means. But basically, I want to show you how you can generate code without having the excuse that using AST is a long, that you need to write a lot of code just to write a lead binding. So I will show you exactly what an AST is, how to generate code from F# code, and we are going to also attempt to create our own fabulous AST widget that will, remove most of the boilerplate, the boilerplate that you need to write in order to generate code. So just to give you an example, Fabulous AST works on top of Fantomas Core, which is a library that itself allow you to generate code. So you don't actually need Fabulous AST to generate code. You can do it right now today without this library, just using Fantomas Core, and they have a great support for that. So you can see here, for example, in this snippet, what we are trying to this is the code that you will need to generate a lead binding. Let's say let x equal to 12, and this is what you will need in order to this to print that just single line. So it is close to, I don't know, maybe I don't know the lines, but maybe close to 30 lines or less. And then you have the library that I'm working on, which is called Fabulous AST, which works on top of that. And it's just, I don't know, 3 lines plus the, I guess, open Fantomas Core, and then calling the format async, and that will do it. So you can see that there is a lot of boilerplate reduction here. So yeah, without further ado, let me share my slides. I prepared some slides. So, all right, let me know. Can you see my slides? Good. I assume that it's good. So yeah, the library I'm going to talk about is called Fabulous AST, and it's like generating code like a pro. Well, that's maybe discussable, but yeah, I think it will help a lot in the code generation. So what is AST? And in order to understand that, I guess we need to, define what those 3 letters means. AST. AST stands for abstract syntax tree, and is a data structure or abstract representation of the source code that you are writing, that most or some of the programming languages it uses to basically represent the tokens and all of that. So from the user point of view, you don't really need, with my library, you don't need to know more about about what every single node of the AST and the F# compiler means. All you need to know that there are widgets that will, for example, say record, and it will allow you to create a record without needing to know that this is a structure needs to conform this and that. But yeah, and let's say as a high level, it's called AST, and it's abstract syntax tree, and it's a tree-like data structure that represents the syntactic structure of the source code in a programming language, in this case, F#. It is a DSL that stands for domain specific language, specifically for F#, and it uses behind the scenes the UI primitives of a library called Fabulous that I will show you a little bit in a few slides. But the most important thing, it uses the already battle tested and proved Fantomas API to generate code. And this is good because basically using Fantomas, you will generate code that is already being formatted using the F# code formatting guidelines. So you are not basically will be introducing your own format, or the way you want to do that. It will use a already defined format that is standard across across the language, and and most people use it. I personally use it, so I think for me that's a really win and a really benefit. But the most important takeaway from this, I guess, from this presentation will be like, don't use string concatenations when generating F# code. Use AST instead. And you know, one of the reasons is like working with strings sometimes is dangerous, and you know, really you cannot really I guess guarantee that the output of the generated code will be valid, because it is, you know, if you miss a space, if you miss if you know, miss any string manipulation, or you made a mistake along the way of the code generation, then you know, it's really difficult to then go back and try to really look at the string manipulation and see where did you go, when anything go wrong. In the other side, if you use AST, there's a guarantee that the AST is already the source representation of the code, is the syntactic representation of the code. So there is a really high chance that your code will be well generated, it will conform to the language, and it will be formatted, you know, as a benefit with using Fantomas, will be formatted in the right way. Again, this is what I show in the other side at the beginning of the presentation. Just to generate a let x12, you can generate it and you have this amount of code. With my library, you just need to open a couple namespaces and then you just generate the value that in this case is a let binding. So yeah, without further ado, I think let's show some code and see how the Fabulous AST library works. Any questions so far? No. So that's good then. Check the chat maybe. No. Right. So as I say, the name Fabulous AST, it uses two different I guess concepts. The first one is the Fabulous UI framework, which is a DSL basically, that is a UI DSL that allow you to use our widget, so Swift UI like DSL, but for .NET for F#. And I'm really fan of that DSL. So you know, what I did was basically try to use that UI ergonomics and that UI concept into something that is not, you know, is not related to UI, which is an AST. So I guess from a developer point of view, if I use HTML, if I use I don't know, Flutter, Compose, most of them now they have a declarative DSL. So that's why I basically did this. The alternative of not using a DSL, of course, is to just, you know, if you want to create generate code using Fantomas, as they rightly say here, is they show you, this is the Fantomas code generation documentation. And then here they show you how you can generate the let binding. And this is basically, I took this in my slide. So this is where it is coming from. And yeah, the only, let's say, thing that you need to do is write a lot of helper functions in order to generate the intermediate nodes that AST has. So, you know, there will be, you try to generate something, but then you will need to generate a lot of helper functions just to generate all the boilerplate. But with my library, that it's already done for you. You just use a high level widget, you pass the required information, and that will generate that. But yeah, going back to what I was saying about Fabulous, what I did was I took the primitives of Fabulous and just extracted in something that doesn't have a state, because as you know, most of the any UI application that you are going to be using, it needs to handle some state. In this case, it uses MVU, but you know, with the AST, there's no state there. So we don't care about anything state management. All I did is just take all of the primitives and put them on the Fabulous AST library that will show you in a little bit. And the other one, as I say, is Fantomas. So Fantomas has a really awesome tool called Fantomas tool. That's why the guys make a really good choose decision in the name. So Fantomas tools, and this is actually the best tool I have found when it regards to. I don't think there is any other tool like this. No, even in other communities where you want to understand how how the code is represented in an AST format. So the F# compiler provides an AST by default, which is something like this. So yeah, this is the AST, and it is close to 62 lines, and it has a lot of information there that is not even relevant for when you're trying to generate code. And I think there's also regular. I think expanded is the one. Yeah, and what the Fantomas did, the team did, was create a new syntax tree called oak. And what it does is remove all the noise that is not needed for when you are working with AST, and you are and I think internally for them is even it help them to capture the information, the really relevant information that they need to use in order to format your code to understand the AST. So if you go to the oak tab, you will see that it will go from 62 lines to, let's have a look. So 2, 3, 4, 5, 6, 7, 8 lines. This is already amazing in terms of the nodes of the data structure you will need to conform in order to generate this. So for this, it's like that, but you can have I don't know, a discriminated union that will have, I don't know, red, blue, and then trying to get this. It is less code. So this will allow you to write less code. And for my library, when I saw this, is like I can work with. I didn't want to deal with this, to be honest, when creating the library, and what I wanted is to use something more compact and more more easy to use. So that's why the Fabulous AST library uses the oak model. Okay, that's okay.
While we are here, Edgar, sorry to interrupt, but I want to clarify two things maybe.
Yeah,
One of the reasons we're also using Oak is to store code comments. So if you could write a comment after red or blue, yeah, wonderful. So if you look at this, we assigned the comments to the last red identifier. But if you go and look in the other AST tab, like the I'm a comment, you'll if you try and search for that string, you won't find it.
yeah, there's
Um,
nothing.
so the actual comments are not represented as a note in the compiler parser, and that was one limitation we had in Phantomus. To restore these code comments, we need to assign them to like the correct node or have a bit of a notion of how to deal with this. And that's also one of the motivations to create the internal oak structure. And another thing, if you were to change this tab to a signature file, so in the
Yeah,
settings over here,
remember that like
yeah,
this.
if you so you can see the first line parsed input SIG file. So for signature, these are all different nodes. But if you were to go to the oak tab, there's no such thing as a difference between an
Oh,
oak
nice.
when it comes to implementation and signature. So that also simplifies, printing back out the code, and was also one of the reasons that we went with the oak model.
Yeah, no, also I really like that you can actually select the ranges here. That's really cool.
You're able to do that in the AST tab as well. So if you
Ah,
click
nice.
on an actual range over here, then it also selects it.
Oh, wow, that's cool. Thank you very much. Right, thank you for that clarification, Florian. Right. Well, okay. So, I guess the next step is to explain a little bit the internals, if yeah, of the Fabulous AST. So the Fabulous AST has two important concepts. The first one is the let's start from, I guess, from a unit test, so we can actually understand this. So value, if you look at the oak model, uh, you basically, in order to generate a value, let me go back to here, value. This is how would you represent a value, a lead binding. So this, run this, it will succeed, but it is just basically you need the anonymous module. In this case, I'm not really typing any namespace or any module itself. I just want the lead binding without anything. So that's why it's an anonymous module, and this is following the naming convention that the actual oak model uses. So in this case, if I go back to, wait, it's the wrong thing. But in order to generate a model, all we need is to create, some boilerplate that you might think is a lot, but it is actually, this is a boilerplate that Fabulous require in order to, so in order that the user can enjoy that single widget. But on here is basically create a type, inherit from the binding node that the org model requires, and then passing the information here. So when you create a binding, in this case, you only care about the name and the value itself. So let x equal to 12. And in this case, it's not typed, so you don't have any type annotation there. So you only care about the name. So if I go here, it only requires this name here. So we can pass the default information or no information to the rest. And what Fabulous does is create some attributes here. So the name is the only one that is going to be required. And how do we know it's required? Because it's the only one that is being passed through the constructor here. So the constructor is when you initialize the widget, you pass the name and the value. So these are the only two things that you really need to create a binding value. And yeah, you can see here, you don't no longer need to write this. All you need to write is this. But yeah, there's a little bit of boilerplate that we are handling, or I am handling for you there. And if I go to, I guess, to the builders, there's no actual magic behind the scenes. This is just a builder where we have different constructors, and then we use a internal data structure to hold the attributes, and to make it easy for us. And we have a computation expression that implements, the normal stuff. This is the zero, the yield, the combine, all of them, and then internally allow you to, for example, to have something like this, or to have an anonymous module that is a collection builder. So if out here, there's two concepts, widget builder and then collection builder. Widget builders is only holds a widget information, and when it's a collection builder, you can have multiple widgets inside. And the rest is yeah, stuff that it was moved from Fabulous to this library. So this is a lot of plumbing code that needs to be there. All right. Any questions so far in this? I guess it's a little bit, it's really difficult to explain behind the scenes how Fabulous will, do the whole computation expression, how it will handle the binding, the yield, the bind, overrides from the computation expression, but it is easy to say that you don't need to worry about that. This is just if someone wants to really understand behind the scenes how Fabulous works, please let me know. Write me a DM on Twitter or here, and I'm happy to to go more in detail with that. So yeah, what I have done so far is write, I think, 106 tests to really test that I'm doing the right thing. And what I mean by that is like I'm, creating the right constructors or initializing the binding, the oak data structures in the right way. So, just to show you what I have done so far. We have a simple lead binding, then we have lead binding inline. So in order to make a value inline, you need to just use a modifier that will say make it inline. That, to be honest, I don't, maybe this is not the right way to do it, and maybe we should have a inline value or inline value, something like that. I don't know. Still kind of trying to, find out what will be the better ergonomic way to do this. But so far, I have this. So, but yeah, I will think more about this and see what is the last thing I will decide before reaching 1.0. For now is I think 0.6 still, so I still have a lot of versions to break stuff, but hopefully it should be stable. Same thing here. So for example, you want to make a value private, you need to use the accessibility modifier from the AST, and it will basically give you this. Then you have internal, you have all of that, and as Florian said, we have the possibility to add docs here. So if you want to add some docs to your code, you can basically say, okay, I have this lead binding, I want to add a comment. So, you can generate even comments on this. And this is available on all the different, and all the different nodes. So you can add in records, you can have comments on record fields, on union fields, everywhere where we can use the XML docs property from the AST, it will be there. You can add multiple lines like this. You can add attributes. You can say, for example, I got the value x12, and you can say, okay, I want to make it obsolete. And this again will work in all the places where the AST allow you to put the attributes. There's a nice thing also that you can, because it is a lot of code to wrap or to bind with this library. I decided that you can also use escape hatch. An escape hatch is that I will allow you to write the oak model just by basically using that without having to wrap anything. So this is escape hatch in case I don't have I don't have time to support all the different nodes from the AST. You will still be able to to use them. So it's not like you need to wait for me to wrap the whole thing. You start today, you can do that. And there's a couple of examples I will show you in a little bit. Same here, instead of this anonymous module, you can write just this, and then the code will be generated. You have mutable here, all of that. Literals. This is similar to a value, but it is just that I made a shortcut, so you don't need to basically add the literal as a attribute. So you don't need to do value dot attribute literal. You can basically just use the constructor literal, and that will create that for you. So you can also, because this is a computation expression, you can also write basically a for loop inside, and then you can generate all in one. So this is what I meant by that you can use F# code to generate this. So you can have your custom logic there. You can read from a file. You can read from a I don't know, from a API, and then deserialize that and pass the information to the map the values to the AST, and that will work. So you can see here. You can see here. There's this. All this is the few lines of code that you will need to generate all of this. And if you put this maybe on Fantomas tool, you will see that the lines of code will be, I don't know how many, but it will be more than 3 or 4 for sure. Yeah, same. You have here comments as well, functions. And this is something I think I'm still working on this. But yeah, basically in order to generate a function, and that you will pass its names x, and then gets an I as a parameter argument, and then returns unit. All you need to do is to have this a function which name is this, and then the parameters is in an array, and then the escape hatch will pass the then expression, which is going to be something that's still not wrapped on Fabulous, but at some time will. So here you see you will need to generate your own thing, but you know the thing is that in the future I will have to have some like maybe const expression widget that will receive this information, and that will be only just one widget that you need to use in order to generate that. For now, there's escape hatch. I think if I remove this, this even will work if the overrides for the collection builder are okay. No, because there's a missing yield somewhere. Right, but the idea is that will work as well. Right, anything more interesting? For example, how do you generate opens? You want to generate your code, but you will need to generate some opens there. So there is just an easy way to generate this, which is basically say open ABC, which is I guess just convenient and useful. And here you can have open dot this blah 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 blah, so you can define this. But this is not only that. You can also, you have open types. So you have the same open type ABC, and these what we'll do is basically add this open type. So yeah, just basically use simple widgets for this, and you can see you can also pass the open type, but pass a oak node, and then you will see that it will still work. But let's go to a one that is interesting, the anonymous module. The anonymous module is basically, as I say, in order to show just a LED binding or any binding, and you don't want it to be wrapping a module on that, all you need to do is wrap this into a widget builder, which is the anonymous module, and here you can have a call, you can have a value. There's going to be X, and then it's going to be like that. You can have I guess, a record. Now you can have like this, and then you can pass what's the name of the record. The record is called A, and then you have a field, which is going to be of type, I guess, C, and then the field type here is going to be a common type dot in32, and this will what this will do is generate a call, a printfn. Is it useful to be here? No. Is it going to even compile? I don't think it will compile, because you cannot put this on outside of in namespace. So at least you need to have something there. You have a record here, so all of this will work. So if I run this, and but yeah, the rest is basically the same. I can go on and on showing what I have done so far, but I guess the most interesting, I think, part will be to show you how we can create a new, how can we add support to generate a new piece of code, I don't know, let's say for example a lambda or maybe I don't know, active pattern or maybe a unit to measure, let's see. But as you can see here, the test failed because now we have more than this. So in order to this to work, we need to have another lead binding, and Copilot will help me. Yes, please. So yeah, but I think it produces too much code. So if I run this, if Copilot did the job properly, they should pass. But anyway, I think pass and pass, we can move on to see something. Oh yeah, what is failing here is that needs to be like this. You see, this is a Fantomas taking care of for you of the formatting. So you don't need to worry about that. It will produce the right code formatted in the standard way. No need to worry about that. So you don't even need to use Fantomas, Fantomas to then reformat the generated code. Will be ready. So. Right, we have a green one here. Let me revert that for now because this is not the place where it should be, but just to showcase what can be done. Right, so going back to this amazing tool. So how do you generate a measure? No, yes, like this, right? And then you do type, and then do like that. Will this compile? Will this generate a valid AST? Yes. I mean, I don't know. I mean, I guess you can put it also here. Oh, I'm using Windows and I am using the wrong bindings. Right. I think both will work. But just to test something. Yeah. Okay. So if we go to Oak, what I always do is go to Fantomas tools, see the generated AST, and then kind of understand what this does. And because I already know about this, I have a little bit more of a mental model of how this should work. But as I can see here, this is inside of a module or namespace node. Then it is a type name node. That has a multiple attribute list node, which is the unit of measure attribute. And it defines the bracket, the greater sign, the sign. Then it also defines the measure text, close the attribute, puts the type, a string or single text node there, and then pass this one here. Right, so let's attempt to create this one here. Before I do that, let me run all the tests to make sure I don't have anything failing. All right, all passing. Nice. So let's put this inside of my type definitions. And let's I guess let's do speed and let's go with measure unit of measure. Let's go with measure now. Okay, and the way the Fabulous AST works is basically the generation of the constructor is always the same. You need a module, you need some attribute definitions, and then you need to define your constructor, and then you need to create the widgets, the widget builders, so you can use that, and then you need to generate the relevant yield overrides, so you can remove all the boilerplate there. So yeah, let's start with this. So let me change this to measure, and I'm going to copy this one here, change it here, and if we go back to the Fantomas tools, this is a type name node. So this is not an abbreviation, so we don't need this. So all we need is to keep this. So if we cut this, remove this, paste this, that should work, I guess. But all I need is another parenthesis somewhere. Yes, here. We don't need the alias type because this is not how the measure works. Then what I need is a what I need is to change the name here as well, and then we can look at the AST again. But if I change this to measure, and this is due that we want to support the strings. We also want to support a single text node, and then we also want to support a widget. And this here will allow us to use escape hatch. So you can use the oak nodes without really needing to if you need to generate a really complex widget that is or code that is not even still is not supported with Fabulous AST, you can use that. But yeah, you will see it in a minute. So I don't need the alias type anymore. So alias type goes here. Then measure, and this is failing because I need to call, I'm not calling abbreviation anymore. This is now a measure here. So I should do this. And this is not working because of this. And then it's going to be working because of this. Right, so now I need to remove this. And I have a one here that's empty. Right, so we got that. Now let me change the key because this was pointing to abbreviation before, and now it doesn't need to do that. All right. Now, so we still need the type, but I guess what I need to find out now is, before we do this, let me use Fantomas to do the formatting for me. Do I have it somewhere? Yes. Oh, yes. So I need to do .NET tools, code restore. All right. Do I have Fantomas? Yes, I have it. Now let's do the right. Well, where I am.
Are you on .NET 8?
Yes.
I think there's still an issue with some of the earlier SDKs about restoring tools. I think you have to restore it manually. Like you have to do like .NET tool restore Phantomus or something.
But yeah, it's not a big deal. Just I will just come at this like this. Okay. So yeah, we have this, and the last part is I need to find out where this type name node is is who is owning that type name node, what type of type definition is, because that's something that it's always the case to be able to wrap to have that support for the abbreviation. So the easy thing is to go to the source code, go to the Fantomas Coreless syntax oak, and then look for that. So we find that is here. It's here, it's here. It must be a place where it's a type definition. So let me look for this. Here it is. So it is a type definition and it's known. So, okay. So what I need to do is to go back to measure and here use the node known, right? This is failing because I need to do this. I find the copy this. So do this and then do this. Then do this to one. Will work. This is just to allow us to use the DSL in order to not to be able to write that measure inside. Okay, now I need to look for the attributes here. So the attributes is the second one. All right, and it is an optional. So if I copy this, then do some and do this. You see the wrong again, the wrong. Okay, so and then I might have a something here that is something like this. Okay, so let me check something. If I go to this and because I don't remember. I have a here it is. Right. So yeah, if I copy this, then paste this one here, what this will allow me is to have my own, and then here we put a right? And what it does for us is going to basically introduce this attribute there, so you don't need to do it by yourself. And is the equal a unit of measure doesn't have an equal after the name of the type, so we can get rid of this. And I think that will do it. We don't need this anymore. Name, measure, name. Okay. Abbreviation, here's an error. This will fail because it is still pointing to the name of that. So you need to make sure that you're in the right thing. So measure with value and then compile, measure with single text node will work, and then measure with a string will work. So another thing we're missing because it's just copy and paste code is that the actual collection builder type name is duplicated, and there's a rule that you cannot have the two same types, I think, with the same type name when you're overriding when you are overriding yields or any computation expression function there. So you need to make sure of that. And yeah, so the best way to test this is to have a unit test. So sure, right. And then what we'll do is I'm going to remove all of this. Put this string right, and I'm going to have this, and then it's going to be produces a unit of And then here, if I do measure and then I do send, it compiles because we added the right overrides for the yield. And then will also produce that. This produce function, what is quickly, that is just a helper that will, compile. I guess the compile is a wrong name for it, but basically will transform the DSL into Oak, which is what the Fantomas core API is expecting. And then you pass the configuration here. The nice thing about using also Fantomas is that you can pass a configuration here. So there is a lot, when I mean a lot of different settings that you can type for this. So if I'm not wrong, these are all the settings that you can choose. It's not here, sorry. Yeah. You see all of these settings here. Is it, David, is it all of those settings map into this?
So all.
So what I mean by that is, for example, if I go to the here and I want to pass a different configuration for Fantomas config default and then I override this, can I assume that let's say all of these properties that are in these settings here are also settable in the other in that structure?
Yeah, sure.
Okay, cool. So you can see you can even generate code and just set the configuration defaults to what you want. So, that will even be easier for standardize the code. Okay, so if I go back to here, so what do we expect? I think Copilot is giving me the code, but basically, yeah, this is what I will expect. It will expect the unit of measure that is without any module or any namespace, and what it does is just created that. Based on my configuration, will this be or will be this? But let's basically run the test and find out. This will go with compiler things, but let's see what the actual Fantomas is going to give us, because I trust Fantomas more than Copilot. So I think I need to build the thing, I guess. No, it actually passed. So Copilot and Fantomas were in the right way. Let's close the previous run and run it from scratch, because I added a new file and all of that. So just in case. It is abbreviation, we have measures, and we have this. Okay, it should be okay then. Cool, but let's do something more complicated, I guess. Let's have a for loop here. I can say for and in then pass. I don't know how many things we have. Centimeters. We have I don't know. Let's have let's see what Copilot give us. Give me something, Copilot, perfect. And then I should be able to say this, and then I will be able to do that. Okay, so is this not working? Why? So internal object.
Semicolons instead of.
My God, I hate that. So I need to change that to be like
Someone should write an analyzer for it.
yeah. It's always tripped me with when I'm using different languages now, and some of them, they didn't make the mistake of using commas and all of that stuff. That's why columns, but But yeah, if I run this, let's see what Fantoma says. I have a feeling that after adding the file, something is not going really. I think I need to restart my writer.
I actually think Fabulous AST isn't compiling. Could you go back to the widget measure file?
Which in the measure file? Yep.
If you scroll to line 32, 33, it's still abbreviation builders.
Ah, shit. Yeah, yeah. Good eye, my friend. Good eye.
Well, I wasn't quite sure if that was relevant or not,
Yeah,
but
that can be what the problem. But there is nothing wrong with doing a good old close the solution and reopen again. Not the end of the world. Give it a sec. Or just checking the how many was before, how many is now, and what is obviously the will allow it to write. Yep. So let's run this again and see. Because yeah, before it was passing, but it was suspicious that was passing because I was expecting this to be in the in a line, and then this will be in a second line. Now it seems like it is building the project as well, so I have more confidence with this one. Oh no, yeah, here it is. It's failing. All right, that's perfect. I like when this fails. Yes, so I made a mistake somewhere, which is that I'm using this one here. So, all right, so let's have a look. Where I made a mistake? Uh-huh, here it is. I'm pointing to the wrong type. Okay, so I do this. So now it is type name node measure, and this should do it. Go back to the tests. Jimmy raised a really good point. I can use even an analyzer on the Fabulous AST to make sure I'm following the right conventions. I'm doing the right thing. Right, you can see now. Yeah, it is expected this, but we got a different result. So what Fantomas is giving us is something like this. Compile do your magic. Thank you. Thank you. And thank you. No, this is not it. Thank you. So we got sentiment, and I have another one, which is the career. Right. All right. So if I run this, Right, this is just a example of what you can do, but imagine I will show you in a bit. I think I saw a PR on the Ionide LSP repo that they are using Fabulous AST to generate you see it's passing, and we have some generated code in the 1, 2, 3, 4 lines. All of this just to generate all of this code, which is really cool in my opinion. But yeah, I might be biased because I like Fabulous. So. Uh, so yeah, what else we can do? I mean, now this is just the beginning, because now, as you can see here, type node has attributes, has a leading keyword, has a identifier, has implicit constructors, all of that equal and all of that. So it is interesting because if you read the F# documentation for unit measure, you can add support for that. Let's say you want to add a comment on this. So you have XML comments. So you can add a property here that will say XML comments, and then you will add a extension method here that so you can do for example like this and say dot XML. Oh my God. Comments, and then you can add something like this, and you can add your comment here. So that will allow you to do that. But for a demo purposes, I think yeah, this is actually a demo that it didn't fail miserably. So it is good, and I show you how to create a widget for that. So yeah, what is next, or what I want to do with the library is, I guess the last thing I want to talk is I want to finish the library and support, let's say, all of the widgets that will make sense to be able to generate code. So I will go through the Fantomas syntax oak and add all the relevant widgets so it is easy to generate. I'm not going to add wrap everything, because there are just cases where it doesn't really make sense. It will be generating all of these boilerplate just for something that can be done in a syntax node, which just one line or one helper function. So I will add it when it's actually necessary. From the language perspective, I want to implement a suggestion in F# that will allow us to have empty computation expressions. So I think if I go to label, hopefully it will be somewhere here. There's a author. Maybe if I do this. Basically, there is a suggestion that will allow you to support this. So if I go back to my measure, you cannot have this. This fails because you cannot have a empty builder. So same happens, for example, let's say you use let's say this sequence. So here you cannot have an empty sequence like this. So I want to add that I want to implement that in that suggestion that is somewhere here, and that will really make the life of this library really useful. Anyway, somewhere. And the other one is, but this is a more complicated one, is like so far in order to, for example, add more, in order to add more to add modifiers to a collection builder like this, you cannot do this. You cannot do this. I don't know, my stuff. You cannot add a modifier, so you cannot access to the modifiers right after the curly brace. You will always need to wrap a in parentheses. That's just how the I guess the name resolution works. I don't know what's the term for that, but basically that's just how that works. So this is not allowed, and I will love to have that. It's still not approved, but my hope is by 24 I will manage to convince Don to or someone from the team to really allow us to do this. But yeah, that's basically it. So any question, any critique, anything, everything is welcome.
Would it be possible to take a look at that ionite code you talked
Ah,
about?
yeah, sorry, yeah, my God. So yes, please. So if I go to generate types, and this is on the Ionite live server protocol, and this is a PR by Jimmy, and this uses a this trying to generate the I guess the code that is depending on the meta model.json that is I think it's huge, it's 40,000 something lines. And what this is doing here in this long file is
Yeah, just let me get the like elevator
yes,
pitch for this thing
yes,
real
please.
quick. The language server protocol is the thing that powers basically every editor now, more or less every editor nowadays. And it has lots of things to cover. And so there's tons of data types and tons of different types of requests. And it's really easy to forget a property or do a property incorrect or whatever. And because like basically the current status of the language server protocol, the INIDE one is it's all been I think handwritten. I think it's all been handwritten. Maybe it was initially generated, but it's been like constantly hand updated. And so the kind of elevator pitch is, well,
Wow.
there's a meta model now that the language server protocol team has put out that's supposed to, I see bugs occasionally, supposed to have all the correct types and what they're going to be doing for the request response stuff. And so why not generate F# code from that? And so if they ever change things, we just get new stuff.
Yeah, that
That's the
makes sense.
pitch.
I just expanded the JSON file and GitHub just freaked out and look, it's rendering in chunks. It's getting really confused. So I will kind of not do that. I just want to see the generated code just to see where is the point where you are using that. But yeah, you're just reading from IO, blah blah, and at some point
Yes,
here,
there's like basically two steps you have to do here. They have like a schema and then they have like the actual like data model. And so then you have to look at the schema to kind of infer certain types about or reason about the certain types because they have things that are kind of the same thing that you would do in F#, which is like a file URL is a string, but it's its own thing and kind of stuff like that. So you got to make some like interpretations of what's going on there. But then once it reads that, it kind of goes through and reads the meta model, and then we try to generate types from that. And then there's a lot of different cases from there, and maybe there's some things that either I didn't understand, and I just kind of so that like I am using a lot of the escape code hatch, and maybe some of the stuff has
yeah, it's
been
already supported. Yeah, yeah.
T regardless, but there's been a lot of but this kind of gets us like I think it actually generates all the stuff correct at this point. I think there's nothing
Okay.
wrong.
I can see here. Yeah, it's basically this. Yeah, this is exactly what the Fabulous AST is useful for. So you have the namespace where you generate the namespace, you say, okay, make it recursive, and then you pass type aliases that I call it the abbreviation. Maybe I should call it type alias, but anyway. And here you will say, okay, I have an abbreviation, which is this, and then basically using the escape hatch now generate this. And you know, do as many as you want, and then you pass three compile.source, and then you call Fantomas, and Fantomas will do for you, and you're writing to a file. So that's really cool. Yeah, that's the I mean one of my main motivation was that I am the maintainer of Fabulous MAUI controls, Fabulous Avalonia, all of that, and we have a lot of code to generate. Imagine all of these Avalonia DLL, so the Avalonia API is huge. So you have to generate the same kind of stuff for I don't know, let's show a view and let's show, I don't know, a control and let's use a calendar, for example. So all of this, it has the same pattern. It all has an interface, has a module, and then has this kind of code. So what for me, it was really useful to basically say, okay, I can read from the DLL, I can read the types, I can, create my all this code and just do it in less than 20 lines and then have generated 170 lines. And if this is just a small one, but if we go, for example, to a bigger one, like which one will be interesting? Visual, I guess. You have more stuff here. So this is actually the motivation for the library was to be able to generate that and not die in trying, because it was a lot of code. So yeah, the last I think week will be like, is this something different that, or what is this compared to Myriad? Myriad is a completely different, a different concept. That is, Myriad is it generates code, but it generates code based on I think MS Build plugin or MS Build integration, where it will be more. It is a more powerful tool that in terms of that can both, I think, be used in a way. I think so. There must be a way where both tools can be used to do something. I haven't really used Myriad much, but I think it is a really powerful tool for code generation. So yeah, that's it from me, guys.
Myriad is kind of like the nuts and bolts that lets it interact between MS Build and like your like source target. Um, it has because like it's basically three parts, which is like one, figuring out how to ingest some type of source information. So like in some cases that would be like maybe a JSON schema. It could also be an F# file itself. It could be many things. It could actually be just a regular text file or something. Then two, it's running like taking that input, running the thing that generates their source code, and then three is outputting that source code and then knowing when to track changes. So that's what Myriad kind of does. In this particular case, like we could swap out the port because like Myriad doesn't really care that you're using the AST. It's just
Exactly, yeah.
here's a function I call, give me source code out. So like this is a perfect, like you could use Myriad with this.
That's I think that's the next step for me, is to try to get both work together. But there's also cases where you want to generate members on your class. So far what I come out is something like this. You have an anonymous mode, you have a class with a name, you have a property, name member, I guess. And I just format this in an easy way, but you can have something like this. You can have your class and you can have that's that you have this. So I'm still not 100% happy with how this is. That's why I will merge. Maybe I want to find a better ergonomics for this, but it's try and error until you find something that this actually works. So, but yeah, that's it from me for today. Thank you very much for having me and for listening to me. So yeah, if you don't have any other question, cool. Let me. Uh, so yeah,
I
thank you
just want to
everyone.
say, like, I liked using it. Obviously we still got some pieces missing that we would want to add to it, but like I liked the little wrapper over it in general, just because I've done a lot of code generation in the past,
Yeah,
and
definitely.
I end up writing basically some helpers that kind of more or less do what you're trying to do in a more structured way.
Okay, before we go, let me show again our newly restyled website. So again, this is Amplifying F# 2.0. I guess we can call it a website where you have a lot of information, the same information and more with regarding the initiatives that we are working on, but with a more I think more nice styling. So again, if you're interested in learning F# and you want to get from from knowing the basics to the core types, introduction to pattern matching functions, composition, function composition with effects and collection, know about function validation, pattern matching, all of this, please visit our webpage, amplifyingf#.github.io, F# Essentials, and on here you can leave us your email and we will notify you when we are going to have our first session. You can also see this amazing video created by one of the F# members, sorry, one of the members of the F# community. And here, I don't know, you can hear, maybe you don't hear the voices, it's too low, but yeah, have a watch this one here and you will see what are we trying to do. But yeah, without further ado, thank you very much, everyone, and I wish you a really nice weekend.